Hello and welcome to my video on mechanical energy. So this topic is covered extensively in Science 10 as well. So mechanical energy is the addition of kinetic and potential energies. And in this lesson we'll look at gravitational potential, but in the next lesson, I believe it is, we're also looking at the elastic potential energy as well. So gravitational potential energy is measured as mgh. And we briefly saw that in the last video. And kinetic energy is measured in mv squared over 2. Okay? Or a half mv squared. Those two mean the same thing. Okay, there's a whole bunch of descriptions on what those all mean. But yeah, that's that. Now, this is going to come up more when we start talking about conservation of energy. But basically, mechanical energy is oftentimes conserved. So if you have energy at the beginning, and you, like, let's say you have a ball and you drop it onto the ground, well, that energy that it had at the beginning, that height that it had at the beginning, now changes to some sort of velocity. Okay? So the energy at the beginning changes to the energy at the end. So keep that in mind while we're trying these questions out, these examples. All right, the first example. A 195-gram ball is dropped from a height of 2.30 meters. Determine the ball's kinetic energy as it contacts the ground at maximum possible velocity. Basically, it starts with a height at the beginning, and it's dropped, and so that entire potential energy transfers into the kinetic energy at the end. So the kinetic energy at the end. So I'll put final and initial here, which is going to become more important in the next, in that conservation of energy topic that I was hinting at. So anyways, it has a height. We know the mass. We know gravity. So let's go ahead and write that in. So mgh equals EKF. So we know m is 195, and we always want that in kilograms, so 0.195 kilograms. And then we got gravity, 9.81 meters per second squared. That's the acceleration due to gravity. Then we have the height, which is 2.30 meters. And so we're just going to simply be multiplying all of those together in my calculator right now. So we get 4.39975 joules. So with 3 sig digs, that would be 4.40 joules. All right, so all of the potential energy converted into kinetic energy, and that's going to happen most of the time. All right, let's take a look at the next one. Calculate the speed of an electron in a television tube if its kinetic energy is equal to that, and the mass of the electron is equal to that. Okay, so now what we're doing is we're going to say, oh yeah, EK equals a half mv squared. We know the mass and we know the kinetic energy. What we're looking for is the velocity. So we're going to rearrange this. So it's 2 times EK, over m equals velocity squared. Well, that's not quite done yet. So we just divided by m multiplied by 2. Now we have to square root both sides. So square root of 2 EK over m equals velocity. So let's go ahead and try that out for ourselves. So 2 times the kinetic energy, so 9.0 times 10 to the negative 18 joules over 9.11 times 10 to the negative 31 kilograms. All right, So this is going to be giving us our velocity. Let's go ahead and plug this into our calculator. Oh, I had it wrong. There you go. 9 times 10 to the negative 18. 9.11 times 10 to the negative 31. All right, and so the velocity is 4445054 meters per second. So this would be how many sig digs? 2 sig digs it looks like. So 4.4 times 10 to the 1, 2, 3, 4, 5, 6 meters per second. All right, and our last question has a 21 kilogram anvil, has a gravitational potential energy of that relative to the ground. Calculate the height above the ground. So this is very similar, except now it's potential energy. So potential energy equals mgh. We're solving for our height, so we're going to divide by mg on both sides. So EP over mg. So in this case, that is 370 joules divided by 21 kilograms times by 9.81 meters per second squared. So this would be 370 over 21 times 9.81. So 1.796 meters. And that is 2 sig digs, so 1.8 meters would be the correct answer. Alright, so I hope this video helps you better understand mechanical energy, so the introduction to potential and kinetic energies. If you want to go back to Science 10, I recommend taking a look at my playlist for that, as there are a bunch of videos involved there as well for other examples, more examples of mechanical energy, potential energy, kinetic energy, and conservation of energy as well. Hope this video helped, and good luck.